Thank you.
Here's Kyle Scoville. Now, Kyle did his MS with Professor Burdett. So you can see that you actually get jobs when you get out and get to do cool things. This is his project. Is that cool? This is like a really awesome thing to be working on. So the idea is we're going to walk around. Let's start from the ground up and move around. You know, Kyle, one thing that I am curious about is when you did the initial layout of where cranes went, tower crane, who did that analysis for you guys the first time?
Me, Eric.
You did. And how'd you optimize where to place it there?
Well, actually, I wasn't supposed to go there at first. We had planned and bid the job for it to go down there by street.
Wow.
I guess
Can you all hear?
I wasn't.
You can come forward. You know, it's okay.
I wasn't involved in the initial decision. I think that's just where we determined we could run temporary power to the easiest.
Yeah.
But we just realized as we got into the job, space down there wasn't going to be easy to get by. Getting trucks in and out wasn't going to be easy. And then you had the power lines to contend with, and we didn't want to fight any regulations on how far away you could be from power lines, airspace permits, things like that.
Yeah.
So we moved it up here just for this initial drive. And we just had, well, another governing factor was, I guess there's different types of tower cranes and tower crane bases.
Yeah.
And this one that we are renting requires 4 caissons at all 4 corners, and there wasn't enough room down there to get that base in and provide any access in around the site. So it had to get moved up here. We had to relocate to temporary power. And this actually isn't ideal either, because as you come up this drive and go back to the back of the site, we're actually supposed to be about even with the second floor in terms of grade. The second floor will actually be the first floor to students.
Yeah.
First floor will be more like a basement as you enter down from the street. So we'll have to backfill around the crane, then move the crane, and backfill where the crane was. So
Really?
there wasn't a good spot for it. The caissons dictated where that one.
Now, did you have to come up with the money for the caissons also? That was part of the cost of construction. You put it all on. Good. Okay, so I wanted to get a general idea of placement of the crane, you know, that side access, because we're going to ask some of those questions as we move along, you know, with the crane study stuff that we're doing. I also, what I want to do is start from the lower floors and work up, and I want to make sure we get up on the deck. We're going to be here for about an hour. Great. So why don't we just go over into the high bay right now, start at that level, look at the formwork, and then we'll start to move up through the structure so you can see what's down there right now. Okay?
I'll just make a general note real quick.
Yes.
We've tried to clean up the first floor as best we can, because as we move up, we take out the shores from the previous floor, clean it out, and reshore it. The deck up here just got done. There's a lot of stray lumber, a lot of stray nails. I asked that everybody try and wear boots. It's dark down here if we do go into the first floor, other than the high bay area, so just be aware of where you're stepping, because you might hit a nail. That's why we sign waivers. But,
Yep.
and especially be careful climbing the ladder, stray rebar.
Right. So it's going to be testing. We have the strong floor and strong walls, right? The covers are all here. You can see how these all pop off. You going to drill a hole in those or something? Or
No.
magnetic lift? Cool. So, again, the first thing is, look, in terms of the shoring, this is all commercial shoring. It comes up, commercial formwork on top. These are aluminum beams. They have tack strips on top of them, so the guys can tack in plywood right to it. I think these 4x4 posts with those slip jam couplers are really cool. That really saves you a lot of time. It also saves them time in terms of leveling things out. They can jam it tight and get it up against it, and then it locks. So it's a really effective way of holding up this sort of system. Now, have you stripped out in this area? Can we walk up?
Once we have, you have to have 3 levels of shoring the entire time. So once we pour the next floor and the 4th floor, we can pull these out.
And do you have any?
This floor.
I was wondering. I saw shoring plans in here one time.
Yeah.
If you see those, let's pull those out and look at them real quick. It's interesting. They're in your office. Okay, cool. So, you know, these guys have been going in here, and we're going to go on top and look at how they do this. But this is negative space formwork, right? So the guys had to build these boxes, and then they put the steel in for the beams all the way around, and then they come back and cast the concrete on top of that. So that's the general process for doing these different areas. Now, you're going to have all exposed utility? What happened here?
It's exposed on the 1st and 2nd floors.
Is it
Mainly.
Are they going to have drop ceilings in this area?
Not down here. If so, it's very sparse.
Okay.
3rd floor and up. 1st and 2nd floor are more of your industrial look.
Right.
Bare walls, stained concrete, not a lot of finishes. 3rd floor and up, you get into your drop ceilings, your VCT tiles, your carpets, things like that.
Right.
This is more lab space and storage and whatnot.
Right. Yeah, the geotech lab's going to be down here, all that kind of stuff. So lateral bracing, just one thing you want to get out of this, what you want to start to see is general spacing of the shores. So you know, if you're doing calculations, you have something to go on. You can say, okay, look, these are on 16, 18-inch centers. Some of these look like 24. It's in that range, but you want to get the general feel. So everything you're going to be looking at today, use it as a guide for your future calculations, right? That's a big thing you get out of it. So here's these jams, so they can bear directly on the post. So what do you get out of a post like this? I think it's about 3,200 pounds, I think it is, in that range. So that comes in. You know, these are really cool clamps. And it's all frictional connection here, right? So it's just jamming that way, so it's bearing and friction all the way along. You can see where these guys have whacked these to get them up tight, right? They're jamming those hard.
There's actually an attachment that they have that goes on the sides, and it's a crane. So
It is, huh?
the lever that sits on top of this one pushes this one down, this one up.
Yeah, you can actually see the jack marks right here. I hadn't seen them do that. Huh. That's a cool tool. So any questions down in this area? I think what would be good is for us to walk back out in the high bay. We'll go look at what's going on over there. There's a crane system that's going to be in here. So we'll look at the corbels for the cranes and understand what's going on over there. And then we'll work our way up. Huh? Yeah?
Second me right there.
Mechanical penetration for ductwork.
Any questions over there? Okay, let's go back out. Be careful where you're walking. We'll turn left and head down a couple of ways.
My craft force is responsible for pulling the columns. And, you know, we set a budget at the beginning of the job for labor, materials, equipment, and whatnot. And so it's at a set number, and we found that after pours, when we stripped the forms, we noticed a lot of honeycombing. And I guess this corbel right here, you can see at the bottom of it, it just looks like, you can see, aggregate, you don't get a real slick finish on the outside. You have to go back and get a grout or an epoxy mix and cover that up to get a smooth finish. So just extra time, it's extra money that you got to spend fixing the aesthetic look of something that we really don't have time or money to do keep schedule. So we switched over to a self-consolidating concrete mix, which means typically when we pour concrete, you have to vibrate it to get the voids out. And technically, you can over-vibrate concrete and you can under-vibrate concrete. And so we just have not found that balance with the columns yet. And so to eliminate having to go back to a lot of rework, self-consolidating concrete removes the vibrating factor from it. You should not have to, and you should get a real smooth finish because you get a real soupy mix. So like on the columns, we're supposed to have a slump of 6. I believe it's a 6. With the self-consolidated, it's so liquidy, you can't do your normal cone test. You do a spread test, and it spreads out into a huge circle on the ground, which I think our limit is a 26-inch diameter spread.
And then they back correlate that spread to strength?
And to give you an idea, our columns are a 5,000 psi mix. We poured last Friday some columns, got back our 3-day break today, and it was 6,100 psi. So we're already over strength in 3 days.
How fast are you able to strip the columns?
What?
How fast after casting are you able to strip the columns?
The next day. At that rate.
That's pretty good.
You usually want to get 75% of your strength, but the mixes that these guys have been sending us have been off the charts. And so we had one issue where strength was low compared to all the others, but once we got the 28-day strength back, it was fine, so we were good. We took the risk. But everything else has been far surpassing requirements.
Is there not an increase in cost for self-consolidating concrete?
I think it's like $4 a yard. We don't have enough columns and enough yardage to really make a huge dent in it.
Yeah.
We poured 8 columns today, 22 by 22 inches, and about 13 feet tall. It's only 10 yards, $40.
Yeah, that's worth it.
It's worth, you save that in labor.
Yeah. That's really cool.
At what point did you decide to make the switch? Which floor?
Third.
So in terms of this test area, we're going to have an overhead crane, and it'll be riding on these corbels. It'll move back and forth so we can move equipment. There's some holes, some pits right over here. Right, see how they cast in the pits? That's going to be for geotechnical testing. So we'll be working over there. You can see all this, the cans are all on the floor. So these all have anchor heads to them that go down to the base of the strong floor. So we can come into any of these cans and open them up and tie down our test equipment right here. So it's a very effective way of getting things down. And we can set up a lot of experiments in the building. So it works out great for us. I'm really excited. I know the other professors are really excited to get in here and start doing the testing. I think we're going to try to get some dynamic tests going off the strong walls, right? And then there's the whole new hydro lab that's coming on board, hydraulics lab. So that's happening. Any questions down here? Because what I want to do is take you up top and have you start looking at the formwork, because we see this now, but what's interesting is to see how it gets formed and steel placed. And the top floor still got some exposed rebar?
No, we poured on Friday.
Oh, did
so
you?
you won't see any slab steel.
Oh, okay.
I'm just saying like straight pieces.
Oh, yeah. No, okay. So, do we want to walk around the end at all and see some end view over here, and then we can go up, or we just want to go up? Right, the elevators are here, stairwells here,
Elevators are inside.
right here,
Yeah.
and
Stairwell,
yeah,
retaining walls, planters, storage building.
storage, yeah. And then we're going to have storage, outside storage over here too, right?
It's up to you.
They called that the boneyard, I think, on the drawings.
That's what we did. Well,
Just
there you went.
right over here, you know, because as the road comes around. So one thing is, like, you see the patch job there they've already done here, right? So here they're patching stuff up. You see that? They use a styrofoam so they come in and they can block out. That's, I assume, masonry that's going to go in there, right? So that they've got the ties. Here are all the through ties, right? The snap ties. Here's a bunch of snap ties. As they go through, that's what you're seeing here. And they'll break these off as they cut through. A lot of anchors. These are self-tap. They'll drill and the taps. These are extremely strong, so they can tie things together that way. And then here's all the bearing plates for these. Right? Now remember, on the bearing plates, those are already pre-sized, so they have uniform distribution, so you don't have bending issues. So essentially you have solid pressure all the way across, whether you're on whalers or studs or whatever. They'll work really well for you right there. So they've been forming up, and I've been watching these guys right here. These guys doing the columns. Now they're moving all the concrete over for the columns in a bucket. And they're doing a drop from the bucket into the formwork. Each one, right? So everything else is being pumped in through the pumper truck. You can see the spoils from the pumper truck when they clean out. That's over here. It's all part of the planning that you have to do, is to think about where you're going to dump the leftovers from a concrete pour, so you can come back and clean it up easily later on. Just bust it up with a jackhammer, load it up into a truck, and take it away. And that's what's happening over here. They've designated that area for that job, for that task. Some of the formwork coming in here. What sort of questions do you have? This is for you to ask questions. That's why we're here. No? Okay, well, one is that you should be thinking about are, again, staging of the concrete truck and the pumper truck when they do this sort of job. That's a huge part of this, is to get it in the right place and have enough boom to boom out and get to all the corners as you go around. So I'm certain Kyle did, pulled out his compass, and started laying stuff out with his compass, right, to scale, to make sure he could get access all the way around. And now, when you put that out to bid for various pumpers to come in, is there a certain radius size that you're limited to, or how's that work? I've never bid those out.
The quotes we get for pump companies, they'll give you a price per boom.
Boom length, right? That's how they do it?
So, depending on what you need, you've got your price ahead of time. So.
Right.
I think the guy we're using gave us 6 different boom prices. I think we use a 52 meter boom for this last one, which is the highest that they've got.
How much concrete's in the hose when they bring that over? Because they got to dump all that, right?
When they come over?
Is it a couple yards?
Yeah.
Right? Yeah, so they got to waste. That's how much waste they're going to have in the hose that's in the boom. So they're going to finish pouring an area, right? And then they got to turn off the pump and move the boom someplace, and then let all that material come out of the hose. Then they got to wash it out, right? I mean, concrete, you just got to make sure everything's absolutely clean when you work with concrete. So that's a big planning part for the contractor to have that site designated.
There was just a flat per day rate.
They charge by the hour and by the yard.
And how many operators come with the pump truck?
1 to 2.
1 to 2. They got one guy working the bin that they're putting.
Yeah, this last time we poured on Friday, we had one guy come, and so there may have been 2. I wasn't here early enough, but one guy will get out of the truck, make sure things are going smoothly, his truck's back up to it.
Right.
Typically, our concrete supplier has been here to help supervise the concrete coming into the truck, and the pump guy will be on the deck with like control box and joysticks, which
Yeah.
actually moves the pump around. So we had one guy here doing that, and our concrete supplier was watching the truck. But
Right.
sometimes we've had two guys.
Huh. A lot of timber, right? One thing I've been really impressed with Messer is that they have really good formwork, and they spend the money to buy good timber, right? Look at these 4x8s, you know, and they smartly reuse what they can, right? That's what they're doing here. But as you look around, mainly when you start to look at the formwork for the concrete, you're getting just one use out of that ply form, right?
No.
The bottoms you're reusing,
Yes.
but the box outs,
They'll reuse anything they can.
can they?
Yeah, I was talking with the foreman the other day. They can't save. They try to save at least 70% of every floor.
Wow, really? That's amazing. That's really good. So when they tack down the box, it's just tacked down, and they just have struts.
You'll see some on the third floor.
Yeah.
They demo it out. It's just some kickers.
Right.
They have pre-formed wall heights.
Right.
Because all our slabs are the same depth. 24 and a half inches long. So the pre-made forms with little kickers on the inside of the form. Then they top it out with some plywood.
Right.
So when they trip up the bottom of the form, they just remove the metal foot and they carefully take off the plywood as they can. They don't just grip it, totally get the head. That's really cool.
Timber it takes to support this, right? Think about the low tap as it comes down. You know, there'll be beams up above that they're laying out. What's your beam space? You're placing directly below the beams?
Yes.
Yeah. So that's where their main load is. So these are, these will span for the floor slab, and then these are picking up the beams as they go across. This all still has to get stripped out. That's the dangerous part, you guys. So when you start stripping this stuff out, man, first of all, stay to the edge. Let the guys that know how to do it. And stuff can spin on you, it can rotate, it can fall real easy, and there's nails and everything. So you have to be really, really careful when you demo this sort of stuff. Then you got all the aluminum beams coming down. I mean, it's a really tough job. I really respect those guys doing this work. Any questions right here? Let's go up. Go. So first thing to notice is look at how cool this slab is.
Did you guys use that new concrete for the slab, just the columns?
Just the columns. Yeah. We haven't had a problem with the honeycombing with this mix on the floors.
What's the cycle time for building up the formwork for this?
6 days
6 days per floor?
per half.
Per half, right? Yeah, okay.
I actually think it's 6 and 8. It might be 6. That half is smaller for whatever reason.
Yeah.
You can see where our control joint is over there. I think that was like for the second or for this floor, it's 250 yards for that floor and 350 yards for this floor. So I think it's slightly off, but about 6 days.
What's the conduit over there? Is that a ground wire or something?
In the column,
Yeah.
lightning protection.
So we're doing columns. We got columns formwork coming in. These guys, go up on these, get it all set up. Again, the crane operator's picking up the concrete, and they've got a big bucket that they're using, and they'll bring it over, and it's a bottom lever, and they just do a dump. What is that? About a yard at a time?
They got some
Just holding it in place. They'll get it alignment and they can then in terms of floor heights and getting everything set, Are they pulling control from some other area and shooting it across? How does that work?
I give them a benchmark. So if you can't see it, it's on. I've had to start from the bottom of the job and come up, but over here I've got a line drawn on the column.
Yeah.
So it's 4 feet above finished floor.
Yeah.
So they'll just take a laser. I guess they put it up for the night. They'll shoot right on the laser and they'll set it to what they need to, and they'll raise their rod up to the bottom of the deck so the laser beeps and they set it that way.
So you're setting control for the whole job.
Mm-hmm.
Cool. Right. So they have to get it on the mark, right? So they're putting it in. So if you're out in the field and you're watching work, that's your responsibility. That's what they have to put it in as, for the 1/4 inch. They're starting to put together part of one of the piers, right? You can see them forming that up. Cool view.
What are they going to do with all this land down here?
That's going to be storage area, so the vehicles can come around. There's going to be some picnic areas. So one thing I noticed when you did your calculations for the Mill Creek Bridge, you did your layout. By and large, everyone made the same error, and you did your layout based on a cross section through the bent that you were creating from the micropiles, right? But remember, everything was skewed. So I didn't see anyone do a top view layout of 4x8 sheets with the skew. For examples, these edges, see how these edges plies come out? Everyone did your calculation on it being, this perfectly rectangular section, but it wasn't, right? It was skewed. So when you do this layout kind of stuff, when you're thinking about your materials, you have to take it down and literally just go into AutoCAD, draw up a 4x8, and start copying that thing and move it around, because on the drawings you have the edge of deck, right? You know where the edge of deck is, so you know you have to have the plywood at least out to the edge of deck, so then you'd have your extensions past that. So make sure you keep that in mind, and if you look, like over here, there's the extension of the ply out past the edge.
Where are you going to put the water tank in, or is that you're going to take that into pieces and put it together once?
When's it going to go in?
Yeah.
Well, technically it hasn't been approved yet, so it won't take long once we get it. I mean, I would say it'd probably take a week or less to install it, but there's no set delivery date for it yet.
So you're just going to drop it in?
Well, it goes over on the other side of the building. This is the elevator.
Okay.
Straight through there, you'll see along those rails. This floor looks a little different than the second floor because there's your main lobby's over there on the second floor, and it's a big atrium. So for 2 or 3 floors, it's open to above, and there's no slab above it. So the water tank will just be placed in from the road over there before storefront glass goes up.
Why is there a water tank?
One is for aesthetics, for civil engineering, just kind of a monumental piece. And 2, I think it will actually be functioning and it will serve your hydraulic slabs.
That's right. It's the hydraulics. So they'll be cycling through that. But it's a stainless steel tank, right? As I remember.
I don't think so.
No, just steel painted?
I think it's some epoxy coated tank.
Interior, excellent.
That's a look.
How are you guys doing towards schedule, and what type of shifts are they typically working here? You got a night work plan?
No, we're on schedule. It's fine. We have lost some days due to rain, but it's something we can't make up. We actually gain days back for rain. You're allowed so many per month, and we claim them. Shift-wise, it's just 5/8. It had been kind of up to the contractor's discretion. These guys were working 10 hours a day. We've chopped them down to 8. The caisson guys who were here originally were working 12 to 14-hour days just to get done and get out. We dictate the schedule, and we feel like we're in good shape. Later, you'll get. I mean, people have worked over. Like my guys have worked overtime. You know, making sure we get a column pour off. You know, but nothing huge. We'll hit the overtime when we try and put the finishes in and get electrical done. They always kind of get the brunt of it.
Yeah.
How much of this job is Messer's skilled labor compared to just subcontracting?
Dollar-wise or percentage-wise?
Activities.
We have the columns. We have the blocking, like miscellaneous rough carpentry. We have doors and hardware. So it's not a lot. I think typically on Messer jobs we get 3 to 5% of the workload. It can be self-performed. A lot of your jobs will regulate how much you can use. UT could have said, you know, Messer, you cannot self-perform any work, and a lot of people that would be here would be me and my boss. They could say you're allowed to do 15%, you know, whatever, but we don't have the capacity here in Knoxville to do all the concrete, so we just did the column parts.
Who's in charge of cleanup? Do you have to go to labor finders, or the subcontractor have to do that?
Per their contracts, every subcontractor is responsible for cleanup daily. No one ever does it.
Yeah.
We don't enforce it too much, but once stuff starts to get a little nasty looking, we put it in our meeting minutes and talk about it. It usually gets cleaned up pretty soon. It's not really an issue, a huge issue right now. It does get to be an issue once you start doing your finishes, because you've got metal studs laying everywhere, drywall dust everywhere, electrical wire, and getting people to sweep up every day is kind of hard. It's a provision we put in contracts so that we don't get stuck with it, but it's something that they kind of agree to off the cuff, but they don't schedule it into their 8-hour day. So they want to do, if the electrician wants to do 8 hours of electrical work, not 7 and 1. But we put that in there so that we don't get stuck with it. And if we decide, hey, you need to do 5 hours of electrical work and 3 hours of cleaning, they're going to do 3 hours of cleaning. And typically what we've done for buildings like this is composite cleanup crews. So we'll take 2 guys from every sub that's out here, and they'll be the cleaning guys. On another job I did, Pellissippi, we had 2 floors. We broke it up into 8 phases or regions, and each subcontractor was responsible for one area of the building. That way, you get away from the argument of, hey, I'm not picking that up, it's not mine. It's just you need to keep this area clean regardless of what it is, so people hold each other more accountable. So if I got to clean up your drywall studs, I'm going to make sure you clean them up, because I don't want to be cleaning them up. So that's kind of the battle you fight there.
So when you come back around in these next few days, watch these guys, how quickly they move on this, and then watch how they start boxing up everything, right? And then the steel guys will bring their stuff in, so they'll be craning all the steel over, the layout. It's pretty interesting. Like right here at this beam, this is actually an interesting detail right here, where these beams come together. You've got all this steel coming in, and it's really almost too much. I mean, it gets really congested right over here. Really tough detail. This one right over in the corner. So they have all these big bars coming in. We've got some pictures online. You know, we've got all this posted. So you can either go to the UT Civil Engineering main page, and then we have a link to all this. And we're going to be posting a bunch of the photographs also, but we have the video that's there. So you can see that. And we go through, and we've been shooting all these areas, so you can see that detail.